Now, there's a second way to find max or mins involving the second derivative. This uses the second derivative, but it's to find max or mins. The second derivative test helps us find max or mins. It's different than using the second derivative to find concavity, so just be careful. Students often mix that up. You cannot use this method to find extrema if you have endpoints. So if you have a closed interval, you have to use the first derivative test for the endpoints. But if you're looking at just an open or at the entire function, no interval, no endpoints, you can use the second derivative test. And we often use this when we're doing the applications because it's faster. So the whole idea is that when we have a max like this, we know that the function is always going to be concave down. So if f of x is concave up at a critical point, and again, the critical point is where the derivative is 0, we know that that critical point is then going to have to be, if it's concave up at a critical point, so this is concave up, and here's would be my critical point where the derivative is 0, we know that critical point will have to be a min. And if my function is concave down at the critical point, then that critical point will have to be a max. Okay, now this is only true, it has to be at a critical point, which is why it doesn't work at the endpoints. But if it's a critical point, then we know that if it's concave up, we are going to have a min at that critical point. If it's concave down, we're going to have a max. So how we do this test is we find the critical points, and then we find the second derivative. We plug the x value of each critical point into the second derivative. If you get positive for the second derivative, f is concave up, and the critical point is a min. If you get negative for the second derivative, f is concave down, and the critical point is a max. So let's look at an example. So this says find the extreme of f of x equals 4 times the quantity 2x minus 6 squared. If I take the derivative, I have to use the chain rule. So I do 4 times 2, keep the inside the same, and then subtract 1, and then multiply by the derivative of the inside, which is 2. And I can multiply 4 times 2 times 2, all the numbers outside. 4 times 2 is 8, times 2 is 16. And we're going to set that equal to 0. Because we're going to find the critical points. So you can divide both sides by 16 to get rid of it, or you could distribute the 16. Either way, it doesn't matter. And then we solve it. It should be 32. Okay, so 96 divided by 32 is 3. So that's my only critical point. So what I do, or critical number, critical value, because we just have the x value. So then what I do is with the second derivative test, I take the second derivative. Okay, so going back, my first derivative was 16 to 2x minus 6. I probably want to distribute that to make it easier. So it's 32x minus 96. If I take the derivative of that, I just get 32. Now, if this wasn't a constant and it was a variable with x, we would just plug the 3 in. But since we get a constant, we know that it's always positive. This is positive, so my function is always concave up, which means at the critical value of x equals 3, we would have a min. So x equals 3 is a min. And if you need, again, the y value, you would plug 3 into the original function to get the y value. So that gives us 6 minus 6, which is 0. So and 0 times anything is just 0. So the 0.30 would be a min. And that's how you do it with the second derivative test.